All right, to wrap up our little lens thing here, what happens if you put this convex lens, which is a diverging lens, in water? Well, it doesn't bend as much because the index of refraction is a smaller difference between water and the glass. In air, there's a bigger difference in the index of refraction, so it bends more than it does in water. So you might notice in water, you go swimming in water, you can't see underwater because the index of refraction of water is almost the same as your eye. Your eye doesn't bend light very much at all, hence you can't form a very good image underwater. Unless you trap air between your eyeball and the water. Then everything looks just fine. That's what a mask does. But as soon as you have water against your eyeball, the light does not get bent as much, and then you can't form an image, and everything's all blurry underwater. Okay? What if instead you made the lens out of water? Well, water being a lower index of refraction than glass, there's less bending. The focal length would be longer for the same curvature. So keep in mind there's two things that go on to make this focal length what it is. One is how curvy, how fat this is. The fatter it is, the more light is bent, the shorter the focal length. Or the higher the index of refraction, the shorter the focal length is. So it's the curviness plus the index of refraction that makes the focal length what it is. Those two things combined. Alrighty. What if you replaced it and you made it an air lens? Well, this is a convex lens that becomes diverging now because now the light gets faster on the inside and it diverges out through this thing, and the lens behaves just in the opposite direction if you had an air lens that was sitting in water. Okay? All right, let's keep on rolling. Okay, chromatic aberration. Those of you who wear glasses, you see this, and you see it not so much in the middle of your lens, you see it on the edge. Because what happens, just like in a diamond and everything else, that the red does not get bent as much as the blue does. The blue interacts more through material, slows down a little more than the red. It gets bent more, hence it's the different focal point, and it makes the colors a little bit distorted, especially on the edges. So that can be straightened out by another lens like this that can put things back together and get rid of some of that, especially on your higher end lenses and your cameras and everything that can have that to help fix that issue, because that is kind of a little bit of a problem. And the higher the index of refraction and the fatter your lenses have to be, it's a bigger issue. Okay? Human eyeball. Well, guys, this is a converging lens because the light comes in, it bends towards the point. And this lens here helps to get to the right spot over here. Let's look at if you want to look at more detail. Well, is it, all right, I didn't know if it was coming or not. And I don't have all day there. So there's the light coming in parallel. So if something really far away comes through the lens, bends through, and focuses back near the optic nerve over there, and that energy hits the optic nerve, excites, sends a signal to the brain. The brain puts that into an image. Alrighty, isn't that fabulous? Back to here. So there you go. There's some muscles on here. And what happens is they have to be a different shape for reading things, to different focus on different things. Things that are closer up, you have to be able to bend this more to put the image on the back of your eyeball. Because things that are close up, the light is diverging quite a bit. Something that's really close to your face, the light reflecting off that is diverging everywhere. You have to bend that light like crazy to focus it on the back of the eye. That means you need a nice fat lens. And when you're nice and young, this is a pretty flexible lens. Those muscles squish that thing, or they can make it so it's a nice fat lens and easy to do. As you get older, this gets less squishy. And it's harder to make that into a rounder, more convex thing to see things closer when you get to be about 40 years old, and you need some reading glasses to help this. You need some fat in the middle reading glasses to help you bend this stuff to help diverge the light. Otherwise, it doesn't hit the right spot back there anymore. So it happens pretty much to everybody. Okay? So to see stuff far away, the light's more parallel coming in. It needs to be a skinnier lens with a longer focal length when it's coming in. But the closer something is, because when something's close, the light is going in all different directions. And able to focus that back in, you need a fatter lens. So to focus on different things, you don't think about this. You're continuously changing the shape of your lens of your eyeball, and it happens without you thinking. When you look at something close, it gets fat. You look at something far away, it gets skinny. You look at something close, it gets fat. Look at something far away, it gets skinny. And it's a good exercise to do to keep your eyes healthy and keep your eyes strong so they're more easily able to focus on things. Alrighty, enough about that. So here's a problem with people who can't bend the light enough. In other words, they're farsighted. They can see stuff far away, but not up close enough because they can't bend the light enough, or their eyeball is just too short. Either way, it's a hyperoptic. It's a fancy word for they can't see stuff up close. So they need something to help them bend or converge the light for them. And that's what this is. You might say, hey, that looks like a concave lens. It's not, because it's fat in the middle. I see it's a round shape on both sides. It's fat in the middle. It's still a convex lens because it's fat in the middle. It helps diverge the light. So people that have trouble seeing up close, they can't converge the light enough, this is a helper. Now on the other side, because this is a convex lens, when you're looking at someone's eyeball, because this eyeball is within the focal length of that, it makes their eyeballs huge and makes them look like a nerd. And it's not that they're a nerd necessarily, they're just farsighted. They can't see the stuff up close. Because that kind of a lens, and the more the problem they have with seeing up close, the fatter the lens has to be, the more of a magnification that gives their eyeballs, makes their eyeballs look really huge, because that's what a convex lens does when the eye is closer than the focal length. It makes it look huge. But that's how you focus stuff. So your parents tend to have these kind of glasses laying around as they get older because their lenses aren't as flexible. They can't make this fat enough, so they need a fat lens to help them out a little bit. So here's my issue. A lot of problem with some of the younger folks as well is the nearsightedness, the myopia. It's that either your eyeball's too long or you're just focusing stuff too early. Either way, you need some help because it converges too much. You need to diverge the light a little bit. So to diverge the light a little bit, you use a concave lens. And you might say, hey, it's still rounded like that on the outside, like a convex. It's thinner in the middle. Because it's thinner in the middle and fatter on the outside, it's still a diverging lens. It spreads the light out so it doesn't focus too early and back on the spot. Hey, yowly pants, quit your yelling at me. This is the first thing that's yelling at me all the time. It's almost dinner time, and that's why he's yowling. He's got an automatic feeder, and I've got nothing to do with it. Go stare at your automatic feeder. Maybe it'll happen faster. Alrighty. So there's your correction then. If you can't see far away, it's because your eyes are bending it too soon, or your eyeballs are too long. Okay? Either way, that's what I'm. Even your contacts. My contacts I wore for years before I got old, and then I had a harder time seeing the up close stuff. They're actually this shape that sits on my eyeball. I chopped one in half one time. Sure enough, it's thin in the middle, fat on the outside. And so before I got old, they worked great for me. Alrighty, let's keep on rolling. Yeah. Okay. So there's your, so telescopes. Telescopes, they use more than one lens. So basically a quick way to make a telescope is, it's that focal length divided by that focal length gives your power. So if this is like 3 times longer than that one, it magnifies it by 3 times. So this one converges it to point, this one takes it back out straight, then your eyeball makes it into an image, and there you go. So that's a quick refracting telescope, how that thing works. Okay. So this is a reflecting telescope. So it actually, we don't really make refracting telescopes anymore like this. I got a little too close to the pause thing over there. I tried to go back. So there's a problem with these kind of lenses, because to see stars and everything, the bigger you need to get more light, you need a bigger lens. So if you have a lens that's twice the diameter, that's really 4 times the area, or you can gather 4 times the light. So you can magnify stuff all you want with a small telescope, but now you're magnifying blurry stuff. It doesn't help much. So to get more detail, you need a wider, a larger lens. So the bigger the lens you have, that's a big friggin' heavy lens, and glass actually kind of flows and bends and deforms over time, and it doesn't always give you the best image. So we don't really use refracting telescopes. What we use are reflecting telescopes, because all you need is a shiny side. They're not big and heavy. And the bigger the area you have, the more light gathering capability you have. So the better image you can have. So if you would have a mirror that's twice the diameter, that's 4 times the amount of light you can gather, or 4 times the detail. So it turns out telescopes are really made by mirrors these days. They don't make them with the lenses. They haven't for hundreds of years, because the lenses are very expensive and hard to make. The mirrors are much easier, and they can give you, and they don't deform the image as much because they're not as heavy. Okay, so there you go. But that's the end of that. All right, have a good time.